Today we are going to graph absolute value functions. The parent function we already have talked about, and it's in our purple chart in the back of your composition book. So today we're going to look closer at parameter changes on these absolute value functions. So to begin, we're always going to start with the vertex. The vertex point is located at HK. And as we know, insiders lie. So for this particular problem, the vertex would be +4, -5. So we're going to go ahead and locate that on our graph, +4, -5. And that's the vertex point. The next thing we're going to do is look at the A value and figure out what the dilation is. Now, the dilation for absolute value functions is the same as rise over run for linear functions, the same as slope. The difference, though, is we're going to actually go in both directions from the vertex. So I'm going to go up 2 and to the right 3 from my vertex point, and I'm also going to go up 2 and left 3 from that vertex point. And on the right side, I can't go any further, so I'm going to go ahead and just repeat on the left side. Up 2. Oh, I missed that one. 1, 2, 3 there. And then up 2, and that one goes off. So then the shape is still a V shape, as we're used to seeing with the parent function. Then I can answer some questions about the graph. So the vertex can be known as either a maximum or minimum point. When the vertex is, when the A value is positive A value, then I get a minimum point because the graph is opening up, as with our standard vertex, our standard absolute value. If the A value is negative, then the graph is actually going to be opening down because we have a reflection across the x-axis. That's going to cause the vertex point then to be a maximum value. It's the highest value on the graph. So in this case, the graph is pointing up because we have a positive A value. So that means that this is a minimum vertex point. The axis of symmetry can be found directly through the vertex going vertically straight down. That helps to remember that that's the axis of symmetry. And when we talk about the axis of symmetry, we're always talking about an equation. So in this case, the equation is a vertical line. So x equals, and it's going through the value of 4. So x equals 4 is the equation for the axis of symmetry. The domain goes from left to right. So as I look at that, I'm noticing that it goes on in both directions. So it goes from -infinity is less than x, which is less than infinity. And then my range starts down here at this minimum value at the vertex and then goes up forever. So it's -5. We're going to go ahead and include it so we have an equals on that, less than or equal to, because we do have the point at -5. And then y is less than infinity. Okay, so let's try a few more of these. Let's actually try writing the equation if we're given the graph. So let's go down here. So we're going to just do the same thing. We're just going to work backwards this time. So I still want to know what the A value is. I want to know what the vertex is and all of that. So the first thing I might find is the vertex point. So I'm going to identify it right there. I'm going to do my best to count the vertex. Oh, here we go. Let's see. Vertex at -1, 8. Okay. Then from that vertex, I'm going to do my best to count the slope. The slope, again, is going to be a rise over run. So I'm looking for where I can see it cross some actual integer ordered pairs here. And I'm looking for a pattern. So that looked like if I go down 1, 2, 3, 4, 5, 1, 2. 2, 3, 4, 5, 1, 2. I'm looking for this repeated pattern that's the same every time. 1, 2, 3, 4, 5, 1, 2. Okay, so the A value is going to be rise over run, so down 5 and over 2. And then it is going to be negative because the graph, the absolute value function, is opening down. So that is going to be a negative A value. So to get the entire equation then, y equals -5/2. Then we need that absolute value bar, x, and then insiders lie, so +1, absolute value bar, and then +8. And there's my equation. And then I can go ahead and identify the domain and range. So the domain still is all real numbers, so -infinity is less than x, which is less than infinity. And then my range, so this time this graph is actually pointing down. It's going down forever. So that's going to be starting at -infinity, and then it comes up and it ends, the most point, the maximum value is up here at +8 on the y-axis. Okay, last example that we can do together. So again, looking at this, how do we write these equations? So I'm first going to start by finding the vertex point. So that's +2, -1. And then again, we're going to count this a value. So it's a rise over run. So we're just looking for a repeated pattern here. So I'm looking like that. Looks like an integer. And it may look like there too. So rise over run. 1, 2, 3, 4. 2, 3, 4. So that looks about even. So it looks like it's rising 1 and running 4. And it's opening up, so it is going to be a +1/4. Okay, like you do now is to go ahead and take that information and write the equation, and then identify the domain and range for this function, remembering that it does go on forever. And be ready to show your teacher the answers to the equation, the domain, and the range. That will be your credit for your homework tonight. Have a good day.